Good morning, students. So, in first chapter, you have learned the set theory. Now, let us take two sets, set A and B. Set A consists red and blue. Set B consists bag, shirt, and jeans. Now, how many pairs can we have? Okay, so we will think about the proper all the possible combinations. So here we can see that red bag can be of red color, or shirt can be of red color, or jeans. So we can have here the combination red bag, red shirt, red jeans, and the another combination will be blue bag, blue shirt, or blue jeans. Okay, so this way here we are getting total 6 combinations. Okay, set A consists 2 elements and set B has 3 elements, and total we are getting here 6 possible ordered pairs. So the definition of Cartesian product is what? So definition of Cartesian product for any set A and B, A cross B. We generally denote Cartesian product by A cross B. So A cross B is equals to all the order where AB, where A first elements belongs to set A and second elements belongs to set B. Here AB is called ordered pair. Okay. Now note that AB is not equals to BA. Okay. When we are writing AB, it doesn't mean is equals to BA. So let us take some examples. For example, let A is equals to 1, 2, 3, B is equals to 3, 4 and C is equals to 4, 5, 6. Now find A cross B. We want to find A cross B. So A cross B will be 1, 3, 1, 4, 2, 3, 2, 4, 3, 3 and 3, 4. So this way we are getting here 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Total we are getting here 6 squares. Now suppose you are taking A cross C. So A cross C will have how many elements? How many order pairs? Any guess? So that will be total 9. 1, 4, 1, 5, 1, 6, then 2, 4, 2, 5, 2, 6, then 3, 4, 3, 5, 3, 6. So A cross C will have total 9 order pairs. Similarly, B cross C, if we find B Cartesian product with C. So B cross C will have 3, 4, 3, 5, 3, 6, 4, 4, 4, 5, 4, 6. Okay. So here we cannot say that 1, 3 is equals to 3, 1. Okay. So in order pair AB is not equals to BA. Here we have B cross A. Now see, in A cross B we had 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Now in B cross A we have 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, 4, 3. So that means the order, the elements interchange. Okay. So generally if xy is not equals to yx, then we can say that A cross B is not equals to B cross A. Okay, so here the order is important. Now if xy is equals to 1, 2. Now if we want to compare two order pairs, so how can we compare? So we have to compare their corresponding elements. So x is equals to 1 and y is equals to 2. Okay, and remember that in all the ordered pairs, first element belongs to first set and second element belongs to second set. Okay, now next we can see that order pairs are equal. So first element of the left side is equals to first element of this. So whenever we want to equate two order pairs, we will equate their corresponding elements. Now example 1. You have this example in your textbook, that if x plus 1 and y minus 2 is equals to 3 comma 1, find the value of x and y. So what we will do here, we will compare their corresponding elements. So x plus 1 is equals to 3 and y minus 2 is equals to 1, and therefore x will be 3 minus 1, that is 2, and y is equals to 1 plus 2, that is 3. Okay, so we will get x is equals to 2 and y is equals to 3. Now, number of elements in A cross B. Okay, Now see, try to recall that earlier we found A cross B. In A we had 1, 2, 3. In B we have 3 and 4. And number of elements in A cross B is 6. So generally whenever you want to find total number of elements in A cross B, what you have to do, number of elements in A multiplied by number of elements in B. So your answer will be 6. Okay. So, similarly, whenever suppose number of elements in A is 5 and number of elements in set B is equals to 6, then answer will be 5 6 are 30. So, your answer will be A cross B will contain 30 order pairs. Okay. Now, here I have one question for you, that if A cross A has 9 elements, then how many elements does set A have? Okay, now we know that A cross A, so number of elements in A cross A is equals to number of A multiplied by number of A, that is number of A square is equals to 9. So, and we know that number of elements will always be natural number. Okay, so if we consider that number of elements in set A is x, so we are getting here x square equals to 9 and therefore x is equals to 3. Okay, so here number of elements in A cross A is equals to number of elements in A multiplied by number of elements of A is equals to number of elements of A square is equals to 9 and therefore A will have total 3 elements. Okay, now exercise 2.1 question number 10. Here see I have selected few sums which are of the same kind. Now the Cartesian product of A cross A has 9 elements, among which -1 0 and 0 1 are found. Find the set A and then remaining elements of A cross A. Now first thing we have to do is find number of elements in set A. Now if A cross A has 9 elements, then we can say that number of elements in A cross A is equals to 9 and therefore number of A square is equals to 9 and hence number of elements in set A is 3. Okay, because 3 multiplied by 3 is 9. Now what they are saying is, here they are saying is two elements are found there, that is -1 0 and 0 1. Now as I told you, first element always belongs to first set. So we can say that -1 belongs to A, similarly 0 belongs to A. Now you can see here we have A cross A. So second element also belongs to set A. Therefore A will have -1 0 and 1. -1 0 and 1. Okay, so our set A is what? -1 0 and 1. Here I have written the explanation that -1 0 belongs to A cross A, that means A -1 belongs to A, 0 belongs to A. Here again 0 belongs to A, 1 belongs to A, that means set A is -1 0 and 1. Another question was find remaining elements of A cross A. Now if you want to find A cross A, then -1 0 1 cross -1 0 1. So your answer will be -1 -1 -1 0 -1 1. 0 -1 0 0 0 1. Okay. So this way you can find out total elements of A cross A, that is -1 -1 -1 0, then -1 1. Okay. Similarly we can find out 0 -1 0 0 0 1. And last one will be 1 -1 1 0 and 1. Got it? Okay. Now example number 3. Here set A is equals to 1 2 3, set B is equals to 3 4 and set C is equals to 4 5 6. Find A cross B intersection C. Now see, Cartesian product we can always take with two sets. And we know that intersection of two sets will always be a set. So first of all here we need to find B intersection C. Now can you tell me what will be the B intersection C? Yes, it is 4. Okay. So now we will take 1 2 3 Cartesian product with 4. So our answer will be, now total elements in A cross B intersection C will be 3 multiplied by 1, that is 3. So we will get 1 4, 2 4, 3 4, 3 order pairs. Okay. Now let us see one more example, that is find out A cross B intersection A cross C. Now here what we need to do, first of all you find out A cross B, then you find out A cross C. Now A cross B will be 1 3 1 4, 2 3 2 4, 3 3 3 4. Similarly we need to find A cross C. So A cross C will be 1 4 1 5 1 6. Okay, 1 4 1 5 1 6, then 2 4 2 5 2 6, 3 4 3 5 3 6. So here we have the order pairs. Now when we want to find the intersection, as I told you in the beginning of the class, that 1 3 is not equals to 3 1. Your order is important. Okay, so just we will see the common order pairs in both these sets. So 1 3 is there in A cross B, but we cannot find 1 3 in A cross C, so we will not consider 1 3. Now 1 4, can we take 1 4? Yes, because here we have 1 4, here also we have 1 4. Similarly here 2 4 2 4 3 4 3 4. So when you take its intersection A cross B intersection A cross C, you will have 1 4 2 4 and 3 4. So 3 order pairs will be there. Now next sum is A is given, B is given, C is given and D is given. Total here you have 4 sets. 1, 2, 1, 2, 3, 4, C is 5, 6 and D is 5, 6, 7, 9. Now we want to verify that A cross B intersection C is equals to A cross B intersection A cross C. This property is same as the distributive law. When we use, instead of cross, we had their union. Okay, and you can also interchange union and intersection. Okay, so how can we do this? So first of all, in LHS we have A cross B intersection C. So we will find out B intersection C first. Now clearly we can see that B and C doesn't have any element in common. Okay, so A cross B intersection C will be 1 2 cross null set. Okay, now 1 2 cross null set will be null set because we don't have any elements to take the cross product with it. So here we will find null set. Now let us see A cross B intersection A cross C. So first of all find out A cross B. A is 1 2 and B is 1 2 3 4. So when we take its cross product, it will be 1 1 1 2 1 3 1 4, then 2 1 2 2 2 3 2 4. So here we are having 8 order pairs. Similarly, A cross C. For A cross C, we will take cross product of 1 2 with 5 6. So here 1 5 1 6 2 5 2 6. Total 4 order pairs are there. Now see, we will check how many order pairs are common in A cross B and in A cross C. But clearly we can see here there is no order pair are equal. Here you can see 1 2, but we don't have any 1 2 over here. 1 5 1 6 2 5 2 6. We don't have 1 5 1 6 2 5 or 2 6 in A cross B. So their intersection will be null set. Now from LHS and RHS we can say that A cross B intersection C is equals to A cross B intersection A cross C. Now next is definition of relation. Now see, whatever we have learned till now was Cartesian product. Now what is relation? So relation is a subset of Cartesian product. We know that Cartesian product always consists order pairs. Okay, so we will select few order pairs out of that depends on our relation, whatever the condition is given. For example, if you are appearing for the exam in 12th science board exam, okay, so if you are in group A, then you have to give maths exam. If you are in group B, then you have to give biology exam. Okay, so as per our condition we select the element. So here relation is a subset of Cartesian product. Now let us take an example. Here we have A, B, C, D is set A. Set B is Aman, Ankit, Baljinder, Chandu and Eklavya. Now we define relation as X is the first letter of Y. So when we are finding A cross B, right, what we will do, we will take X as the first letter of Y. Y belongs to set B. So let us say A, then Aman. A, Ankit, because first letter of Aman and Ankit is A. Similarly, B, so Baljinder, and C for Chandu. I can also take E is equals to Eklavya. But why I am not selecting that? Because A does not contain E. Understood? So we will not consider E and Eklavya as the first element does not belong to the first set. That's it. Our condition is first element should be in first set and second element should be in second set. Okay. So representing relation with arrow is called arrow diagram. So whenever we are we are writing this relation with the Venn diagram, with the help of Venn diagram, that is called, here we are representing this relation with the arrow diagram. Okay, that A is related to Aman as well as A is related to Ankit. Then B is related to Baljinder, C is related to Chandu, and here we can see that D is not related to any elements of set B. Similarly, Eklavya is not related to any element of set E. This is called relation. If we find A cross B, so A cross B will consist of any element. So 1, 2, 3, 4. Here 1, 2, 3, 4, 5. 4 5s are 20. But our relation consists only 1, 2, 3, 4 order pairs. Okay. So basically relation is a subset of Cartesian product. Cartesian product will have so many order pairs, all possible order pairs. Now out of all those order pairs, we will select only few order pairs, okay, which depends on our relation. So basically relation is what? Relation is a subset of Cartesian product. Okay, now see here. Let R be the relation from Q to Q. Means first element also belongs to Q and second element also belongs to Q. Q is a set of rational number. Now it is defined by AB. AB belongs to Q and A minus B belongs to Z. The subtraction should be an integer. Okay. So show that AA belongs to R for all A belongs to Q. What do we want to show? AA belongs to R. Right? Now we know that A minus A will be 0 and 0 belongs to Z. Okay. So whenever the elements of the order pair satisfy the given condition of the relation, then it will belongs to that relation. Here AB is a relation on R if A minus B belongs to Z. Here A and B both are in set Q. Okay. Now we know that A minus B is an integer, right? If A and B both belongs to Z. Here they both belongs to Q. For AA it will be there. Why? Because whether A is fraction or any number, A minus A is always 0 and 0 belongs to Z. Okay. So I hope you have understood today's concept. Okay. And we will meet on the next online lecture. Bye. Have a good day.